We're looking at international and regional frameworks for biosafety, and then we would like to have some discussion on them here. My name is Silas. I work for the NEPAD, AUDA-NEPAD office in Nairobi. The presentation will look at the origin of biosafety, that's the conventional, and then how it was domesticated in Cartagena protocol, and then look at the regional guidelines on gene drives, then on genome editing, and then what I want to convince you is that these international recognized protocols draw a lot on very good science, which is developed by specific bodies, yes. To contextualize, at the Africa Union, we have got a socio-economic development plan for 50 years, and that determines the framework of where Africa is going in the next 50 years here. And Africa needs to be transformed into an integrated, prosperous, and peaceful Africa, driven by citizens, and then representing a dynamic international force. It starts 2013 up to 2063. Yeah. We also, by the way, when I say Africa, I mean Africa Union member countries. It's your government that made these decisions. We have got a science, technology, innovation strategy. In other words, we believe that it's only when you use science across agriculture, energy, and many other sectors that our continent will develop here. So we appreciate and we emphasize the use of science. The other important thing is that I think this those who come from Kenya, no, this is a Kenyan, is a late Callistus, yes. He was given a task by African Union member states to determine how biotechnology can be used in Africa and where it is important here. His conclusion was that it can be used to alleviate food and nutrition security, health, and environment here. And that it can be used in agriculture, in animal, in health, and forestry, yes. And it is out of this report from Africa that it was decided that the African Biosafety Network of Expertise should be formed to build capacity in African Union member states. Today, we are on the ground in 23 African member states here. So, the gist of the topic here, the biosafety emanates from this convention on biodiversity that came into force in 1993. It has got 3 objectives. 1, to conserve biodiversity. 2, to ensure sustainable use. 3, to ensure sustainable development. Now, I won't belabor much on how we can equitably share the biosafety. That's covered under the Nagoya Protocol. But in terms of Cartagena Protocol is an international agreement which aims to ensure safe handling and transport of living modified organisms here. There is another protocol that comes out of it, but I won't focus on it. So when you talk of biosafety, it is CBD, the Cartagena Protocol, and that's where now the regulations on biosafety emanate from globally in the countries that have already signed here. What 3 things come out of that is that one of the most important tools that is used by IBC or anybody else to ensure safety is risk assessment. They describe how you should do risk assessment. 2, the definition, the internationally recognized definition of what GMO is also emanates from this Cartagena Protocol here. Ladies and gentlemen, we appreciate scientific definitions, but at the international level, it's the Cartagena Protocol that actually runs the day here of how you define what a GMO is. Now, it was based on living modified organisms, but it has been adapted to refer to GMOs here. The other important thing is that I've got some principles of advanced informed agreement, which I want to get into, but most importantly, the biosafety clearing house is managed by them here. If you want to know how many GMOs have been commercialized in the world today, just type in the Biosafety Clearing House of CBD. Among crops, now we've got 541 events approved here, about 2-3 animals here. That is found that. But as IBC, the most important tool in making a decision about biosafety is risk assessment. It's defined by the Cartagena Protocol on biosafety. That's the most important tool out of it here. Now, when the Cartagena Protocol was signed and ratified, countries were expected to domesticate it. The first party that helped in domestication was UNEP-GEF. In phase 1, it did about 18 countries in Africa. Domestication means you develop laws, you develop policies, you develop administrative systems of how to receive applications, how to monitor, and other guidelines on risk assessment here. So this was initiated by UNEP-GEF. Then, of course, Program for Biosafety Systems came on board in 2005 here. It has also supported the domestication of those guidelines here. And then our team, ABN, came in 2008. We are potentially can reach up to 55 African countries, but now we are in 23 countries in biosafety. What has been the outcome of that is this African map you can see now. Some countries, I think, let me go to the next one, looks much better. 14 African member states out of 55 have now got acts and are conducting confined field trials. That came out of that domestication here. 8 African countries have already made decisions and commercialized crops in those areas, yes. And then 8 African countries have got acts, but they are not doing any research to do with CFTs here. I will define what CFTs is later, but that shows the progress. But 31 African member states don't have any acts and don't have any CFTs currently. So, out of that, now you can see that some countries now in green, you can see Ethiopia, Nigeria, Sudan, Ethiopia, Kenya, Malawi, South Africa, Eswatini inside South Africa, and now Ghana. I think Okore is around. Mr. Kore, yes, your country is one of the leaders in West Africa, have now commercialized crops that are being grown commercially. So that is the progress of domestication of that protocol. Now, Annex 3 of the Cartagena Protocol defines how to do risk assessment. It gives outlines. But then out of Annex 3, they have developed guidelines in 2016 that look at guidance on risk assessment of living modified organisms. They cover forestry, but I think for this case, one of the most important things that comes out of it is frameworks for risk assessment. So they look at the roadmap for risk assessment of living modified organisms. They define overarching issues, then how you plan. But the most important thing that comes out of this is what are the steps in risk assessment. Ladies and gentlemen, IBCs, you make decisions based on risk assessment, and that is defined by the Cartagena Protocol. But what I want you to appreciate is that this is in 2016, but the procedure that is used was developed in 1994 by the Environmental Protection Authority of USA. In fact, it's called ecological risk assessment. It's actually, this is what is used in all the countries I know. GMOs are using it, as you shall see. Gene drives are using it, as you'll see later. And also genome editing are using it. So this is the procedure that actually used. Described under CBD, but developed scientifically by EPA. Because of time, I will not go into the steps, because I think the course, their better guys will do that. But I want to appreciate that this first part called problem formulation, I'll come to it, is very, very important here. problem formulation helps you to contextualize the risk assessment based on the environment you live in. I give people an example. There's no need of doing the effect of gene-drive mosquitoes on kangaroos in Africa. Why? Because we don't have kangaroos in Africa, isn't it? Yes. But you can say the effect of gene drives on Maasai goats, isn't it? Yes. So this helps us to contextualize. So you find that other bodies also came up. The first one was EPA and IFSA. Very important reference, by the way. These guys have got top-class scientific opinions on biotechnology. They also describe the steps that are required in risk assessment. You can find they are actually identical with the EPA steps, yes. And I think since you guys will be doing a risk assessment of approval of examples of crops, you will go through all these steps, but appreciate that it's based on very sound science. Yeah. I have tried to bias this towards insects, animals, and so forth, so and less on crops, because I know biocontrol is mainly used in animals. Yeah. Now, this body also has looked at what are the components of the risk assessment that should be done. In other words, if you are, for example, at IBC in Burkina Faso, and you are doing risk assessment, what should you look at? But what I want to appreciate is that this is a big shopping list that puts everything in yes. And it can be expensive if you expect people to study all those things. So to contextualize it, you use problem formulation, which I'll cover just briefly, but hopefully you'll do it in more detail later. So you find things like vertical gene flow, horizontal gene flow, persistence of genetic, and international release. These are covered under that, and this specifically for mosquitoes, yes. Now, you'll find when you go to CBD also, they describe similar things familiar to you, that what you should do a risk assessment to ensure that the product is safe. Let me put this as a simple way of looking at a problem for formulation here. And I'll give maybe a different example. Maybe you have got a GMO mosquito, yes, indeed, yes. That GMO mosquito is making a certain protein, isn't it? Okay, maybe the protein is Cas9, isn't it? Yes, which is the enzyme actually. Then, so you ask yourself, when you take untransformed mosquitoes and the transformed mosquitoes, the difference is what? Is the Cas protein being made by the transformed mosquito. If you believe that, so I was saying, what genotype, it can be phenotype or genotype, what genotype found in the GMO that is not found in the GMO, and what does it affect? You can put here Maasai goats, yes. But then you must show step by step how you think a Cas protein comes from a mosquito and moves step by step and affects the fertility of Maasai goats. If you can show that that is a clear pathway, then scientists should study and show the effect of gene-drive mosquitoes on Maasai goats. If it's not, then that is not a valid study. There's no pathway that allows it to go through Achilles. Is that clear, ladies and gentlemen? Or I can give you a simple example, yes. If this mosquito, if this BT cotton, or rather BT maize, you believe it affects our goats, then you are saying that that BT protein must move step by step until our goats eat it and the fertility is affected. Yeah. We know goats eat cassava, so that's possible, isn't it? Yes. But we know lions don't eat cassava, isn't it? Yes. So how? So in other words, when that is possible for you to do, it says it is a plausible pathway. Scientists should study that. What I mean is that don't just tell scientists to study all those things. Each study must be justified by a pathway that makes scientific sense. Now, where do you get this aspect? Every country has got policies on what it is protecting. If it's Kenya, for example, you say, we want to protect our wildlife, or you want to protect the genotype of our goats here. That is called a protection goal. But normally they are very broad. Like, for example, you want to protect wildlife. But you must come from wildlife and specify what wildlife you want to protect. For example, you can say abundance of Maasai goats. Then what aspect of those goats do you think it affects? Fertility of goats. When you move down that step by step, you're now coming at what should actually be studied here. So please, this is an important instrument. Problem formulation. Don't go away until Stanui and the group explains to you what problem formulation is. Because if you do that, you will be asking for a big list of things to be studied here, and it will be too expensive to study here. Okay, now, we covered that properly. Now, ladies and gentlemen, the decision tool, the tool that you have as an IBC or anybody else, even an electrician, even a car manufacturer, to ensure that something is safe, it is a risk assessment. They normally say risk assessment. But broadly, what it means is that you should do a risk analysis, where you do a risk assessment, then plus risk management, and then risk communication. Yeah. It's when you do that risk analysis that now you can tell people this is safe to do in our lab in Burkina Faso, or this is not safe to do our lab in Burkina Faso. Ladies and gentlemen, I'll come to one important point, but let's just go ahead here. So risk, let me emphasize, risk is not a hazard. It's not a toxicity, isn't it? Risk is not allergenicity, yes. Risk is not reduced fertility of Maasai goats, no. Risk is a product of a hazard times the exposure. In other words, you must be exposed here. The best example they give here is that it is safer to travel by the air than travel by public transport in many countries of Africa. It's because the hazard when an aircraft crashes is so higher, but the exposure is so low. So the risk is low, and so it's safer to go by air. Okay. My time is moving here. Now, ladies and gentlemen, this is one of the most important things that maybe I can never share with you, or I will share many important things. You must contextualize the pathway in which the study is being done. For crops, we start with the laboratory, we go for field, then we go for general release, and then we commercialize. And the docket of IBC normally falls between laboratory and confined field trials. That's your area. So anything to do with the risk assessment and risk management you're covering is covering those areas actually. Then here, but so NBA is still running across, but here you are working with NBA as custodians of the first of the institution to ensure things are safe. You can put that also in your perspective of gene drive. They developed a pathway through which you must be able to study. That means from proof of concept to commercialization. Yeah. So any risk assessment, any safety assessments, they are done in that type of pathway. This is so important that if you got the publication, so many scientists, institutions came up and said any study of gene drive mosquitoes must be done within that type of pathway. Yeah. As you shall see, still IBC, you are important at the laboratory and confined field trials. As you go ahead, when you go towards commercialization, now NBA alone is involved here, and still is risk assessment. what I want to emphasize is this. Please, ladies and gentlemen, in the early part of the research, where's my thing on somebody? In the early part of research, I'm missing something very important. Yeah, I think it's just here, but not showing very well here. Yeah, in the early part of research, the scientists don't have all information about safety. They may not tell you everything about safety, because they give you an idea that these genes come from this and they're doing this. So long as they give you good management measures to ensure that it does not affect the health of the people in the lab, it does not affect the environment, you will keep it within that particular place. At the lab is called biological and physical containment. You should approve based on those conditions. Is that clear, ladies and gentlemen? Yeah. So you don't say we will not approve the study of GMO mosquitoes in this country because we don't know about GMO mosquitoes. Say the scientist has provided an application to do the GMO mosquitoes in this country, and he has told us this is the amount of risk he knows, but he has put in management measures. Are those management measures adequate? If they are adequate, you approve, and you ensure that he adheres to those. Yes. Is that clear, ladies and gentlemen? You are very important, guys, because if anything goes wrong at the early part of the research and the environment is harmed at this stage, we are in trouble here. Any questions here? Okay, let me finish. Now, the second last important thing is that whether it's in crops, whether it is in animals, the construct is the primary thing that you look at when analyzing the risk of the science. Is that a clear, gentlemen? Yes. The construct, the gene construct that you are putting in is the primary source of analysis. So at least somebody within the IBC, within the institution, whether you don't like science, please choose some molecular biologists. They should understand what construct has been put in the organism. I was telling guys in Uganda, you can't start telling guys the president, the experiment is going on in this place and it's very safe. And nobody in that place knows even what construct is inside. How do you say it's safe and you don't know what genes they are putting in? You should confidently say, we know the construct that has been put in these genes, and we know the safety of it. We have put in management measures for us to do it. So this is not just for animals only. This is a construct for gene drives, another construct for gene drive. But remember, that is what the primary source of analysis. In the experiment, you'll be analyzing maybe more 8-10. You'll be looking at what does the construct, what is the construct doing to the plant? What is it putting inside here? Before I finish, we have seen that the international protocols talk about risk assessment. They expect you to put in frameworks of risk assessment. And I have told you that at the greenhouse or laboratory or the rest is within the docket here. There is a very important concept that comes from NIH guidelines. And that is the issue of biosafety levels. They define the biosafety levels. And most of the biosafety levels they're using come from NIH. There are 4 biosafety levels, maybe more, things are changing, but the biosafety 1, 2, 3, and 4. 1 is the most stringent, is the least stringent, 4 is the most stringent. And they recommend, just as a rule of thumb, most genetically modified researches are done at biosafety level 2 here. So you'll find that they define, sorry you can't see, this is biosafety levels for large scale preparation. They define for plants, they define for animals, they also define for vertebrates, they also do it for anthropods here. So for anthropods, you will find also they use Anthropod containment 1, containment 2, containment 3, the same conflict here. The goodness with this type of system is that you don't need to cram in the head what biosafety level 2 or 1 should be. What is the containment? What's the biological? They describe it for you clearly. Or your work through the risk assessment. By the way, risk assessment is done by the applicant. Then he submits this to you. Then you do your own internal risk assessment and say whether it's okay. Then you make the approval based on the conditions that have been put in that application. The conditions, most of them are described in these manuals. They're described for you, the conditions here. So, let me come now to the last two topics. Very, very important. When we were in COPMOP 2018 in Egypt, there was a strong move that had put gene drives, genome editing, and synthetic biology together, and the aim was to put a moratorium on it, put an embargo here. But as I shall show later, for Africa, gene drive was very important. I'll explain to you why. Very, very important for control of mosquitoes. By the way, gene drive for control of mosquitoes. So there was a big contest until the moratorium was actually revoked here. But then Africans became interested to know what genome editing is here. Let me first of all cover what gene drive, what came out of it actually is. At Africa Union, we have got experts, African experts plus some international ones, that scout for the most recent technologies in the whole of the world and look at those which are important for Africa. One of them is gene drive, which I'm going to cover. The other one is genome editing put under synthetic biology. So in Africa now we have got a guideline for gene drives and a guideline for genome editing here. This is a genome editing guideline released by AUDA-NEPAD and African Union. You can find it on the website. I hope it's there already. It was released by them recently, just this last month, yes. So, as far as genome editing is concerned, ladies and gentlemen, genome editing covers two categories of aspects. Changes made by enzymes, CRISPR-Cas9, zinc finger nucleases, talents, and meganucleases. Those enzymes make genetic changes. You can program them to make genetic changes in plants, animals, and even humans. Yes. So that's what gene drive comes here. There's a second category called oligonucleotide-directed mutagenesis. It does not use enzymes. You just put in a piece of DNA with one section not matching. When that piece of DNA is used as a template to multiply, it puts in a change in the plant here. And these things, by the way, are not theories. They are being used to make products in the world commercially. Yes. There is a herbicide-resistant crop just made by changing one base. So in Africa, we are focusing on genome editing that covers all those. Ladies and gentlemen, if you look at new breeding techniques, there are many other techniques that are important. But the guideline does not focus on these other techniques. So to contextualize what the guideline is, we are focusing on this because they are of most economic importance. Some of these, they are important, but not of immediate importance. Now, the guidelines has come up with a very interesting perspective here. If we look at conventional crops or animals, there is a way we regulate them. The key steps are those ones for plants. If you look at GMOs, they are regulated. You must do food safety, environmental safety, then you approve the crop, that's crops. Then from there, it goes through the normal system here. What our finding is that genome editing has got very interesting perspective. Some products, you can program them to be equivalent to conventional. And those ones should not be regulated as GMOs. At least many countries in Africa are doing that less. Some products have got an early GMO intermediate, which is removed later. The GMO intermediate is regulated under the Biosafety Act, but after it's removed, then the product goes under conventional regulations, yes. Lastly, the products of genome editing that are entirely GMO up to from the beginning to the end goes under the biosafety laws. And they go food safety, environmental safety, then they are released here. That is basically what is the guideline that we have released, yes. Several countries now have got them. Malawi, Kenya, Ghana, I think also is now moving. Ghana out, yes. Ghana is also moving, and many other countries. There are now about 5 countries. Ethiopia also is moving very fast, yes. Let me come to the most important part of you gentlemen, because I think your interest is in gene drives. And I think please pay attention. Very important. These people release a report every year on the status of malaria in Africa. Now, if you look at malaria in Africa, you will find that, I think just put it simply, scientists have come up and found that if you just use the normal way of controlling malaria, spraying, nets, drugs, and the rest, you will not be able to control malaria at all in the whole world. No. They have come to that conclusion. You must come up with the new tools of controlling malaria. Because as you go through this, sometimes the deaths go up, sometimes they go down, sometimes they increase. There's no clear control of malaria in the world, actually. You may know that they released a new vaccine recently that is still adding value, but still we need other tools. Because of that, the African Union made this statement that commits to invest in development and regulations of gene-drive technology as a way of controlling malaria in Africa. And after committing that, it came up with this guideline, which you can download on your website, yes, that Africa should use gene drives for control of malaria. Ladies and gentlemen, let me underline, it's only for control of malaria. We don't stop other countries from using them, but at least we should use it for malaria. Because, let me just, by the way, make this point clear. You'll find that, I'm rushing, 96% of malaria deaths globally are in 29 countries. Then 4 accounted for about 31%, and I mean for over half, isn't it? Yes. But then Africa is taking about half of the malaria cases in the whole world. Isn't that something that should send us water, Chris? 31% Nigeria, DRC 13%, Niger 4%, Tanzania 4%. In other words, malaria is a problem of Africa. And so we must use all tools to be able to control malaria. The list can go on, but because of time, I don't want to go into many details here. So it's because of that now we said we should use this technology. What I want to emphasize is that the data I'm giving you is the data of 2022, last year actually. But this statement were made in 2017. In other words, from 2017 up to 2022, not much has changed here. We still need gene drive for control of malaria for Africa. Ladies and gentlemen, I can't emphasize it more than that. The guideline WHO gave, I think, 2016 guideline, which is very, very important. I think the revised one, I think, is 2019. But I want to appreciate that this assessment is based on the EPA guideline of 1994. Many of the concepts are borrowed from crop science, GMO, but many of them are near. But this describes the pathway. That pathway I told you is described here. Ladies and gentlemen, to finish, the Convention on Biosafety, on Biodiversity globally met again last year in December to review the progress in biodiversity in the whole world based on those 3 procedures, and this was in Montreal last year. I think many of you were actually there. Mshiri was there, and also Tony. Yes. So the target that is important for biosafety in those conventions is target 17 years. And they said that we should continue to emphasize on those target 18 using Article 19. What it means is that globally, people wanted to bring in so many other aspects in this target that have got no relevancy for us to Africa, although they are important for them actually. That it was difficult to write that target in another way. So they said, since you guys can't agree, and you agreed in 1993, you should continue the work according to 1993. So that's what they say, it should be implemented according to that. In other words, we should continue to take legislative, administrative policy as appropriate to provide effective participation in biological research to ensuring safety. There are many other points there, I never put there, but you can download this on the targets here. How can I conclude? Ladies and gentlemen, you'll say that 2 conventions came out of that, but Cartagena Protocol on biosafety was the most important as far as biosafety is concerned. What are the key elements? It defines what risk assessment is, the key tool for us to make decisions about safety. 2, it defines what GMO is, categorizing GMO from non-GMO. 3, it creates a biosafety clearinghouse from which you can find all approved GMOs in the whole world and biosafety here. It was domesticated here. Gene drive is also an important one, but as far as Africa is concerned, that is a tool for controlling malaria, because malaria is so important. And so hopefully every African country will support the use of gene drive for research. But what makes IBC important is that you need to ensure that the research is done safely in our countries. So we are relying on you, ladies and gentlemen here. Then in genome editing, Africa is mainly focusing on 4 approaches that uses enzymes plus ODM here. And we are finding that some category of the products, depending on how you program, are equivalent to conventional. Some category have got an earlier part that is GMO, then later is removed, yes. And some category appears as GMO here. May I stop there and just appreciate the Biocontrol Consortium for inviting us and many partners we have worked with. Thank you for GeneConvene, we appreciate you. And thank you, young people and young scientists, and because the ball is in your court. Why? You are the one to ensure that the early part of the research, which you are not sure of the safety, is well managed and it does not do havoc to the environment. And thank you very much, and God bless you.